So these word problems, and most word problems, not all, but most word problems really aren't as hard as you think they are. Okay? Usually the problem with solving word problems is students think that there's going to be a huge problem, and they just tend to overthink it, and they don't realize that it could just be really simple. So you set up this mental roadblock. You see, instead of equations, you see a bunch of words, and your mind just freaks out. You've got to just calm down and realize these are normal math problems. You guys, at this level, you're in an honors class, story problems, fractions. It doesn't matter what it is. It's all just math to you guys. One thing's not more difficult than the other. You really have to have that attitude. And you need to approach a story problem saying, I can do this. It may take a little longer. I might have to start something, erase it, and start it again. I might have to persevere. Okay? I might have to be comfortable with a little bit of uncertainty for a while. And that's how you get better at things. If you read a story problem and think, well, I can't do this, I'll just wait for somebody to help me. Are you ever going to get better at it? No. Okay? And the whole reason for learning math is that you can use math to solve everyday real-life problems. Knowing a bunch of formulas and how to use all this stuff, it's great, but it really doesn't help unless you can apply it. And that's what this is. It's called modeling. The actual title of the lesson is called modeling. Okay? All that means is you have some kind of real-world situation and you have to come up with an equation that fits the model or the data, and you solve it to answer some question being asked. That's what mathematical modeling is. So, it looks like we have 6 problems to get through. Can you handle it? Are you up for the challenge? I think you are. Okay. You will find that there is somewhat of a method or an algorithmic approach. Do you know what an algorithm is? It's kind of like a list of steps that you just follow in order. So there is, for most word problem situations, sort of an algorithm. You identify what it is that's being asked. You assign variables to the unknowns. Does this sound familiar? Okay, once you've assigned variables, you have to try to come up with an equation that relates what's being stated. So anyway, so this is section 1.6, and it's called modeling. There's no real objectives other than solve the dang word problems. Write that down for your objective. Solve the dang word problem. No, you don't need to. 1.6. You are going to see a fair number of story or word problems in this course. So this is really good training. Really good training. So let's just go right into it. Example. This is really hard to write with a mouse. There we go. Example 1. I'm going to try to type this stuff. Is there no text input? You got to be kidding me. I have to write. Edit. File. Does anybody see? Oh, insert text. Hey! I don't have to write. Let's see if this works. Yes. All right. Here's example 1. Look at that. A car rental company charges. You need to write this. $30 a day and 15 cents a mile for renting a car. Helen rents a car for 2 days, and her bill, holy smoke, comes to 100. She must have rented like a Ferrari. $108. How many miles did she drive? So starting off relatively easy on this one. So listen to the steps I had said earlier. You first figure out what's being asked. Usually you find the question mark, right? How many miles did she drive? That's what's being asked. Once you've determined the question, you assign a variable. How many miles did she drive? We don't know. So what do we call it? X. Usually it's X. Does it have to be X? No, you can call it whatever you want. M for miles. But anyway, assign a variable. Now, it doesn't really play a part in this problem, but you guys need to be careful when assigning variables. Let's say we had 3 things that we didn't know, right? How many variables would you have to have? 3 variables, right? But the number of equations you have to solve has to match the number of variables. So you got to be careful when you start throwing out variables. Okay? Because you can throw out variables to anything, but then you got to make sure you have that many equations as well. So just be careful. Here we have 1 variable, so all we got to have is 1 equation. So let X equal the number of miles driven. X equals the number of miles driven. So we've gone through the easy parts of solving a story problem. We've identified the question, we've assigned variables. That's the easy part. The hard part is coming up with an equation. That's where students usually struggle. We have to have an equation that relates the given information to the unknown X. Trust me, it gets easier with practice. It really does. It might take a lot of practice, but it gets easier. So how would we calculate her total bill? We know it came to 108, but how did the company calculate that total bill? 2 times 30, where did that come from?
2 days.
2 days, $30 a day, so 2 times 30, but that was just a flat rate. Now we have to do the mileage charge. It's 0.15, or it's 15 cents per mile. Now usually in mathematics, per means we're going to be multiplying something, so 15 cents per mile. How many miles did she drive? X number of miles, so it's 0.15 times X. What is that supposed to equal? 108. See, you guys can do this. Baby steps, right? Baby steps. Now what? Subtract 60. So we have 0.15x equals, oh boy, 108 minus 60. 48. Oh crap. We have a couple of options here. We could divide by 0.15. However, in order to do so, what would we probably have to use? We don't use calculators in here. We can't use calculators in here. Darn it! Are we stuck? You could do it that way. You certainly could, yeah. I know you guys like to avoid fractions. I know and understand that, but fractions will become your friends. Trust me. If you can't use calculators, fractions are so much better than decimal. Okay, so let's consider 0.15 as a fraction, not as a decimal. What does 0.15 really mean? 15 over 100, right? So what is 15 over 100? What does it reduce to? If you divide everything by 5, you get 3/20. So 0.15 is nothing more than 3/20. All right then. Now what do? We could multiply it by the reciprocal, 20/3. You guys don't need a calculator for this. You answer me this easy question. What's 48 times 10? You guys can all do that. What's 48 times 10? 480, right? Now just double that. That's what it means for 20. That's 48 times 10. And then you add that to another 48 times 10. What's 48? What's 480? Double. 960, right? So 480 times 20 is 960, and then just we got to divide that by 3. So 960 divided by 3 is 320. Look at what you guys did without a calculator. Isn't that amazing? She drove for 320 miles. In 2 days, that's a lot. I wonder where she went. She went down to Vegas, probably. Anywho. Well, no, that's more. From here to Vegas is like 600 miles, isn't it? Let's try another example. If that one was fun, you just wait for this one. All right. Anybody remember where that text thing was? Insert, tools, text. All right, this one is a little more sophisticated. Mary inherits, this is my dream, $100,000 and invests it in 2 CDs. Do you guys know what CDs are? No, they're not compact discs like the music. In the financial world, do you know what CDs are? Yeah, it stands for Certificate of Deposit. Have you guys never heard of these? I just didn't want to write Certificate of Deposit. It's kind of like a savings account. You just can't access your money until a certain amount of time. You put money in for 3 or 5 years. They don't earn very much interest. It's like 0.3% interest, but at least it's safe. You don't lose money. Anyway, one certificate pays 6%. Give me a break. No CD pays that. All right, this is in the book, though. And the other pays 4.5%. Simple interest annually. Actually, the CD rate's right about now, or about 3.1 last time I checked. If Mary total interest is $5,025 per year, how much money is invested at each rate? She did the smart thing. Investing. You ever seen these movies or these shows where they win the lottery and buy all this crap and then 5 years later they're broke? It's because those people aren't very intelligent. Stupid people shouldn't be winning the lottery. What's that? I know. Anyway, you invest. You be wise with your money. Yeah. Yes, you sure can. Now, here's what I was trying to explain to you beforehand. Let's first discuss the question. What is being asked here? How much money did she invest into each account, right? She had 2 CDs. So there are 2 things we don't know. You following? The danger is if you say, well, let's let one of them equal X and the other one equal Y, which you can do. What's the problem with that? You'd have to have 2 different equations, and then you'd end up solving a system of equations rather than solving one equation. So the trick in a problem like this is to describe two unknowns using only one variable. And it's not really that hard to do. Once you've seen it a couple of times, you start to recognize, all right, this is not a big deal. But do you understand what I'm talking about? We want to avoid using too many variables because we have to end up solving systems of equations, which is just not fun for anybody. So let's assign the first variable. And since the 6% fund was listed first, let's use that for x. So let's say that let x equal the amount invested into the 6% CD. That's like the greatest CD I've ever heard of. My question is, why didn't she just put it all into the 6%? What was she doing putting money into a smaller percentage? What's that? Maybe. She's against making a ton of money, apparently. Now, what are we going to say equals the amount invested into the 4.5%? We have to be clever about this. We got to be clever. We can't. I mean, we could use another variable, but I want to avoid that because we don't have enough information to make two equations. So what say ye, my brothers and sisters? It can't be the same variable because she already invested x, unless she invested the same exact amount into both, which we don't know. Let me give you a small hint. How much total money did she have? 100,000, right? You guys agree? You guys really need to try to think about this and answer the questions before I give the answer. So she has 100,000 total dollars, yeah? How much has she already invested into the 6%? X. So how much is left? 100,000 minus X. Do you guys agree? She started with 100,000 and she's invested X into some CD. So how much is left over to put into the other fund? 100,000 minus X. So that's what's going to have to be this amount right here. She has 100,000 minus the amount she's already invested into the 6% fund. So this was a way that we could describe two different unknowns using the exact same variable. And this is a really, really useful skill. Okay? It's going to save you a ton of headaches because if you just assign random variables to different things, you're going to have a tough time coming up with equations. Okay? So how much interest did she earn or is she going to earn on her first investment? 6%, so what was the total interest earned in just that account? The total interest was a little over $5,000, but what was the interest earned from just this CD right there that earned 6%? How do you calculate interest? It's the percentage multiplied by what? The amount invested, right? How much money did she put into the 6% account? X. So how much interest was earned? 6% of X. So the interest earned from the 6% account was 0.06 times whatever she invested, X. How much interest was earned from the 4.5% account? Look at what we just did for the other one, 0.06 times X. It's the interest rate multiplied by the investment amount. So what was the interest rate? 4,500 minus 0.05. You can do it like that if you want. Yeah. How do we turn this into a decimal? 4.5% is no good. You can't use percentages in equations. It's 0.045, 0.045. Multiplied, not by X. X is what she invested into the 6% account. It's 100,000 minus X. So this is the interest earned from one account. This was the interest earned from the other account. How much total interest each year? 5,025. So we need an equation now. We have a whole bunch of information. We need an equation that relates to the information given.
So that would be 0.06x.
0.06x
plus
0.045
100,000 minus x
equals
5.5.
Good. There's the equation. That really is the hardest part of all word problems, is setting up that equation. Solving the equations is easy, usually. But setting up the equation tends to cause people some brain problems. All right, what are we doing here? How do we work with this? We're going to have 0.06 x plus Is there a way we could simplify the process here a little bit? We could put it into fractions, I guess. Yeah, we could put it into fractions. Say again?
I'm just for 0.45 would be a time multiply 500,000. And then we get that, and then distribute it out.
Yeah, you could do it. Yeah, there's a lot of different ways you can do this, it sounds like. For sake of time, which we are running out of, are you guys listening carefully? I need you to listen carefully. Just for sake of time for this assignment, the point of these problems is to help you get used to the process of assigning variables and coming up with the equation. That's really the point that you need to practice. If you can assign the variables and come up with the equation, for the homework at least, it'd probably be best to use a calculator for some of these funky numbers. Okay? On the exam, I'm not going to give you a problem that you would really need a calculator for. Like this problem here, I wouldn't give you something like this on a test of this magnitude, because this really would be best to solve with a calculator. Okay? But you are going to have to expect some or word problems on the exam. So just for sake of time, let's bust this out with a calculator, just so we can move on. We have other ones to get to. So 0.045 times 100,000. Want zeros? There we go. So we have 0.06x plus 4,500 plus 0.045x equals 5,025. Minus. You're right. So we got to do 0.06 minus 0.045 to combine the x terms. It's 0.015. So we have 0.015x plus 4,500 equals 5,025. Subtract. And that's 525. So we have 0.015x equals 525. Then divide by 0.015. So solving the equation is one thing. Relating it back to the actual situation represents. I would dock you points for stopping here. You solved the equation, but you haven't answered the question. So what does that mean, x equals 35,000? So you have to state, she invested 35,000 into the 6%. count. Yes. At what point of the equation are you right now?
It's just like at the point of 0 divided x
Equals it. So from here you would divide. So on the calculator, do 525 divided by 0.015.
Okay.
It's 35,000.
Okay, that makes sense.
So if she invested 35,000 into 6% and she only had 100,000 to begin with, how much has she invested into the 4.5? 65,000. This is not, at least in my mind, wise investing. But anyway, get what from? Because she had 100,000 to begin with. She had 100,000 to begin with, right? And she invested 35,000 of it into the 6%. So that leaves 65,000 to invest in the other one. Does that make sense? All right. Let's do a picture one. Example 3. Let's get some drawing going. And I'm terrible at drawing. Draw a square. And then inside the square, like this, draw another square. And then inside the second square, I want you to draw a dodecagon. Just leave it like this. Okay. So, this is a garden with a square walkway (3 feet wide). These types of questions in particular are very common on an ACT. These geometrical reasoning problems. 3 feet wide around the edge. If the area of the entire garden, including the walkway, is 18,000 feet. What are the dimensions of the planted area? That is a big garden. So this is the planted area, this one I'm highlighting here. And this is the walkway.
So I'm assuming it's a square.
Yeah. So this is a square garden. What do we know for sure? We know the area of everything, right? It's 18,000. And the walkway is 3 feet. So I'm going to label that. From here to here is 3 feet. From here to here is 3 feet. Yeah.
Is this with the book?
Mm-hmm. How do we figure out the area of a square? That's an easy question. The area of a square. It's the width times the height, but in this case of a square, the width and the height are exactly the same. Yeah, it's more like side squared is the area of a square. They want the dimensions of the planted area. This one that I've kind of highlighted in red. What's the length from here to here? We don't know what the length is, right? So what do we call it? X. Let X equal the length of the planted area. Let X equal the length or the width, you can call it whatever you want, the length or the width of the planted area. What is now the total length from here all the way to here? Isn't it? X plus, you guys said it, say it louder, X plus 6, right? It's the length of the planted area plus the 2 3-foot areas on the outer edge. So the total length of the entire square guarded planted area and walkway area is X plus 6. What does that mean about this length right up here? That's also X plus 6. Now this number that's been given, 18,000 square feet, that's the area of the entire garden, not just the planted area. So how do we relate what we've been able to figure out now to this given information right here, 18,000? Essentially, that's what we're going to do at the end, yeah. What's the equation, though, that we have to set up? If the area of a square is equal to the side squared, X plus 6 squared equals 18,000. Now we just got to solve for X. So we're going to take the square root on both sides. Again, for your homework, use your calculator, and then expect on the exam to have a problem that you don't really need to use the calculator for. The most important thing here is that you're practicing this setting up an equation. Solving is the easy part. What's the square root of 18,000?
160.5.
Oh, it doesn't come out evenly, huh? Well, that is a bummer. Square root of 18,000. 134, let's use 3 decimal spots to be a little more exact. So X plus 6 equals, I already forgot the number, with 134, 164? Thank you. And subtract 6. I want to subtract 3. What am I doing? Six. 128.164. Feet. What's that? What is it that we're looking for? What is it? Where's the question on here? Let's see. Question. Right here at the end. What are the dimensions of the planted? So, dimensions, what they mean is what's the length and the width, but since it's a square, the length and the width are the same. So, it's essentially 128 feet. If you're talking about planting a garden, I'm going to say, all right, that's 128 point. But if we're going to be exact, it's 128.164 feet. Yeah.
Would it be correct to use it in class
Not in this case. It would make more sense to have an actual number we can look at rather than saying, all right, that's 3 times the square root of 20 feet. You know, you understand what I mean? That it may be more accurate, but it's kind of an unusual number to state in terms of a real life problem. Does that make sense? We got time for more. How we doing, y'all? That good, huh? Here's an interesting problem. I always love these problems. And you do tend to see these on standardized tests, college entrance exams, that sort of thing. This will be our last one. Then we must be done.
Let's just do a,
I know. We just got too caught up. John can paint a house in 4 hours.
that's really fast.
Yeah.
Like insanely fast.
Stewart, I'm just coming up with names. That's an odd name, isn't it? Stewart. Anyway, Stewart can Gesundheit paint a house in, ooh, he's slower, 6 hours.
It's really fast.
Yeah, just come over and paint my house. How long would it take for them to paint a house working together? It's all about cooperation. If they work together, how quickly can they get the job done? That's a good thought. It's not quite the average. It's a really good thought, though. Have you seen a problem like this before? They're all solved the exact same way. Okay? If you have the information of two people working separately, and then it's asked, well, how quickly can they do it together? They're all solved the exact same way, whether they're painting or doing whatever. So you just need to recognize the type of problem this is, and then think, oh, we've solved these before. It's the exact same method every single way, or every single time. You break things up into an hour's worth of work. Okay. The total job, let's let X be the amount of time needed while working together. So X is the total amount of time. Who's going to do more of the work? Why? So John's going to be doing more of the work than Stewart. Okay. If we shrink this down to 1 hour's worth of work, in 1 hour's time, how much of the work will be done by John? A quarter of it, right? He works 4 hours. He can paint a house in 4 hours. So in 1 hour's time, John's going to do, where's my mouse? There it is. John, in 1 hour, does a fourth of the job. Stewart, on the other hand, maybe he's got shorter arms, or I don't know, maybe he's missing a finger. He works slow. In 1 hour, how much is he going to do? He does 1/6 of the job. My grammar is terrible. 1/6 of the job. So together, working together, the total amount of time is X, but in 1 hour's time, how much of the job will they have gotten done? Well, if we add those two numbers together, it would be 5/12. But in terms of X, they would have done, so together, in 1 hour, they have done 1x of the job. X is the amount of time needed to be working together in hours, the amount of time in hours. So the total number of hours is X, but in 1 hour's time, they've done 1/x of this job together. So John is going to do 1/4 of the work. Stuart's going to do 1/6 of the work. Together, that's equal, in 1 hour's time, 1 over x of the work. We saw something kind of like this last time. This is a rational equation to solve. It's a little bit simpler than what we did last time. 1/4 plus 1/6. Really easy to add fractions, you guys. Truly it is. Adding fractions at this point in your math careers should be like riding a bike. Easy. This is 3/12 right here. 1/4 is 3/12. 1/6 is 2/12. If you have 3/12 plus 2/12, you get 5/12. All right, keep going. How do we solve it from here? You could do that. There's probably a number of ways. You're suggesting to multiply by x. That could work. So you'd have 5x 12ths equals 1, and then you can multiply by 12 on the other side. That can certainly work. That's a great way to do it. Solving, have you ever heard of proportions? Raise your hand if you've heard of proportions. All a proportion is 2 equal fractions. 5/12 equals 1 over x. That's a proportion. Okay? When you solve a proportion, you cross multiply. Right? You solve a proportion by cross multiplying. So you're going to get 5x equals 12. And x equals 12/5 hours in terms of hours. Remember, x was in terms of hours. So roughly, what is that? A little over 2 hours, right? 2 hours and 24 minutes? Yeah, they work fast together. You see how much better it is to work together as a team? At least while painting a house, right? Well, I'm proud of you guys. You hung in there. Way to go. Was it as bad as you thought? Do the homework. Don't stop smiling. Get on that UVU process. Yay. Thank you.